Guys, let's do this problem right here. The question is asking to find the P2 gauge. So this is the question. Let's underline this one. The situation is we have a tire that's pressurized by 44 psi. Psi mean pounds per square. Same, it's a unit for the pressure, right? So psi value, then it's at 120 degree Fahrenheit during this one. So the question is asking when this temperature drop to 60 degree Fahrenheit, what's going to be the new P2 gauge? So we are going to calculate this one, and also they are saying V1 and V2 are constant, so these two are going to be equal. So let's see how we can do this. So whenever we have P, T and volume related, we can use combined gas law. That is P1 V1 over T1 is equal to P2 V2 over T2, right? But before we do that, if you look at this one degree, this is the temperature is in degree Fahrenheit. So whenever we use ideal gas equations, we have to always convert this temperature into Kelvin, right? We can't use degree Fahrenheit or degree Celsius. We have to always convert into Kelvin. So that's going to be one of the steps. And also the gauge pressure must be, we have to calculate the total pressure, right? We have to add ATM to this one to calculate the total pressure. So let's calculate the total pressure first and then convert the degree Fahrenheit into Kelvin, right? So let's start with this one, P1 gauge. So we have P1 gauge that is 44 psi. So let's rewrite it in a different way. So we can say P total, that's what we are going to calculate. P total is equal to P gauge, in this case P1 gauge plus ATM, atmospheric pressure. So let's write here PATM. So P gauge is 44 psi, right? 44 psi, psi or psi, something you call that like that. And we know that 1 ATM is equal to 14.7 psi, and if you add them together you will get 58.7 psi. So this is going to be the total psi. So now the question is whether we keep this unit or not, right? Let's see. So here we have volume. So since the volume is constant, we can get rid of this volume right here. We can cancel both sides. So we are going to have P1 over T1 is equal to P2 over T2. So here we are trying to calculate the P2. So P2 is going to be equal to P1 times T2 over T1, right? Since the temperature is in Kelvin, both of them are going to cancel. So this PSI is remaining. So we don't have to worry about converting anything, because if we calculate this total value, the answer is going to be PSI. So we don't have to worry about converting this one into Newton per meter square or anything else, right? So we can keep this in this unit, and let's change the temperature into Kelvin. So let's begin with this one. So to turn degree Fahrenheit into Kelvin, first we have to turn this one into Celsius, right? So to turn this one into Celsius, we have equation. So let's put this one degree Celsius, centigrade, and that's going to be equal to 5 over 9 degree Fahrenheit minus 32. So this is the generic equation to calculate, convert degree Fahrenheit into degree Celsius. Let's apply the value. So this is going to be 5 over 9, and degree Fahrenheit for the first one is going to be 120, right? So 120 minus 32, and that's going to give us the value of 48.1 degrees Celsius. Now we have Celsius. Converting this one into Kelvin is easy. We just add 273 to this value. So that's going to give us 321.9 321.9 So this is 9 right here, right? So yeah, so that's how this makes sense. So this is Kelvin, and then we have, what else we have? So this is what we have, and we have this temperature right here. We have to convert that one into Kelvin too. So let's do that one now. Maybe I continue that one right here. Yeah, let's apply this one at last, right? So let's keep this one right here. So let's convert this one into Kelvin. So we have 60 degree Fahrenheit, so degrees Celsius is going to be, let's put this one, this 2. Yeah. So now let's continue. So this is going to be same equation, 5/9 degree Fahrenheit minus 32. So here we are going to have 5/9 times 60 minus 32, and that's going to give us 15.6 degrees Celsius. So to convert this one into Kelvin, we just add 273 to this one. That's going to give us 288.6 Kelvin. Now we have both of them in Kelvin. All we have to do is calculate the new total pressure. So if you calculate this one, give you total pressure, but then we have to subtract ATF to get the gauge pressure. So let's calculate the total pressure. So here we are going to have P2 is equal to P1, that is 58.7 psi. So 58.7 psi, and then time T2. So this is our T2, 288.6 Kelvin divided by T1, that is 321.9 Kelvin. 321.9 Kelvin, and that is equivalent to 52.6 psi. So this is P2 total. Right now we are trying to find the P gauge. To find this one, we just have to subtract. So P gauge to P2 gauge, maybe a P2 gauge is equal to P total. P2 total is P1 total. P2 total minus ATM. ATM is, just put ATM first and then put the values. So this one is 52.6 psi minus 14.7 psi. That's 1 ATM is equivalent to 14.7 psi, and that is equal to 37.9 psi. So this is going to be the pressure change, the new pressure when we drop the this temperature from 120 degrees Fahrenheit to 60 degree Fahrenheit, and that's how we do this kind of problems. I hope you guys find this video helpful. See you next time.